Okay, this is lesson 6 for unit 2, proportional relationships. We're on pages 170 to 172 in your workbooks. All right, so with a proportion, it's just an equation that states that two ratios or rates are equivalent. So y'all have seen this before where we have a fraction or a ratio on one side and another on the other side of the equation. And you guys have already learned how to solve that. So you call it the butterfly method, right? So we know that cross products of proportions are equal. So if this is equal to this, okay, if AB is equal to CD, then we know that the cross product A times D is equal to C times B, okay? And you all have solved those before. For instance, down here, we've got 6 times 4 is equal to 24, and 8 times 3 is equal to 24. So a lot of times one of those numbers will be missing, and then you would solve for the missing number. We're going to see that in some of these examples. The most important thing when we're talking about these proportional relationships is to make sure that you set up your units and what we're dealing with properly. So they have to line up. In this example, we're talking about the air temperature had risen 7 degrees in 2 hours. So we've got the 2 hours and the 7 degrees. We're going to write a proportion to determine the amount of time it would take to rise an additional 13 degrees. So remember, we have the temperature on the top and the time on the bottom. So when we write on the other side, we have the temperature, how much it has to rise, and the amount of time, because that's what we're looking for. Where does it ask? The amount of time. That's the X. That's our unknown. Okay? So, or in this case, they use T. That's what we're looking for. Okay? But it's very important that our proportion on the other side matches. Temperature is on top, time is on the bottom. Okay? So when we cross multiply, we're going to get that 7 times T and the 13 times 2. We'll set those equal to each other. And then it's an equation, just like we solved in the last chapter, right? We're doing a one-step equation. What's happening to T? It's being multiplied by 7. So to undo it, we're going to divide by 7 on both sides, okay? And when you divide that out, you're going to get 3.7. So that means it will take about 3.7 hours to rise those additional 13 degrees that it's asking. All right, I want you guys to practice. These don't take long. A, B, and C, put those here so that we can check your work. Remember, this will be 10 times X is equal to 36. Okay, so I'll get that one started for you. But I know y'all have done these before, so that should just be a little extra practice. Okay, this next example is tricky. It says if the ratio of type O to if the ratio of type O to non-type O donors at a blood drive was 37 to 43, how many donors would be type O out of 300 donors? So the tricky part here is this ratio. We've got the 37 was type O, and the 43 is not O, okay? Which means altogether, we've got 80 total. And that's the part we need because this is asking out of 300 donors, that 300 is out of total people 300, what would be the type O? So when we set up our proportion, you're going to see we're going to have the type O on the top and the total on the bottom because we're looking for type O out of 300, okay? So we're going to set it up 37 out of 80 were type O, and then we're looking for how many would be type O if we had 300 people, okay? So that's how they came up with this. again, it's super important that you guys make sure that we have the same order on both sides of our proportions. So if on one side we've got type O over the total, this side has to be type O over the total. Okay? So then we just simply cross multiply, and they've done that here for you. 37 times 300 is equal to 80 times T. And when you multiply that out, you're going to get 11,100 equals 80T. When you undo multiply, you're going to divide both sides by 80, and then you'll get your answer. So obviously in this problem, we're talking about people. So 138.75 doesn't really make sense for a person. So they've just rounded and said there would be about 139 type O donors. So if there was 300 people at the blood drive, 139 of them would be type O. All right, the next question is really similar, and I'm going to set this up, and then you guys are going to work on it. The ratio of 7th grade students to 8th grade students in a soccer league is 17 to 23. If there are 200 students in all, how many are in the 7th grade? Okay, so again, we've got 7th were 17 on this soccer league, and 8th graders were 23. Okay, let me get that off of here. No. All right, so in total, there were 40 students playing soccer. So our proportion that we're going to look at would be 7th graders to total students, because this is asking about 200 students in all, how many are in the 7th grade. So our answer needs to be, we're going to need 7th graders over total. So every proportion I set up in this problem is going to follow that same pattern. So in my first example, when it was the smaller amount of students, right here, we had 17 7th graders out of 40 students total. Then on this side, we're looking for, okay, how many students are in the 7th grade? That's our unknown. That's our X. And then if that's our unknown, 200 is our total. Okay? So I want you guys to finish this problem and let me know how many would be in the 7th grade in this situation. Okay? All right, moving on. You guys figured this out when we did unit rates. A lot of you figured out that instead of finding a unit rate, you can just set up a proportion to solve some of the problems that I was asking you to do. So we're going to look at that. In this example, Olivia bought 6 containers of yogurt for $7.68, and they want you to write a proportion to solve for how much she would pay for 10 yogurts at the same price, or at the same rate. So in this problem, they've got cost in dollars over containers of yogurt. Please make sure you're setting this up and you understand what's in the top and what's in the bottom. They have to match, okay? And it looks like, oh, they used the unit rate in this problem. So they set this up and they found out that the $1.28 was what they found was the unit rate. So from there, they just multiplied by 10, you can see right here, to find out that it would be $12.80. But like I was saying, a lot of you figured out that we can set up a proportion. So we could have done $7.68 for 6 of them. Again, like I said, this is what I was talking about. Make sure that the cost goes in the top and our yogurts go in the bottom. That would be equal to X. How much would it cost for 10 yogurts? And then you would solve and get that same $12.80. Okay? So just realize that you have different ways of solving problems, and that's the great thing about math. There's not just one way of solving this. You really could solve for a unit rate, or you could set up a proportion like I showed you down here. The next example does the same thing. So this one, again, they set up a unit rate. They found the unit rate of cost per gallon, and then they said how much would 11 gallons cost, okay? you could set up a proportion to solve the same thing. So right here, I'd like you to, you don't have to solve it, just set up the proportion. What would the other side look like if I've got the $31.12 for 8 gallons, and the question is asking, how much would you pay for 11 gallons? What's the other side of the proportion? Show me what that would look like. And then I would like you to solve this question here. Okay, so E, tell me what E equals. And then just do 2 questions here for practice. And on this question, I'd like you to go ahead and check one of the boxes of how you're feeling about proportions and solving them. So hopefully you guys are feeling really good about solving your proportions and are ready to move on. And you guys did a great job with this. So go ahead and solve those last few questions, and then we will look at the answers and talk about them tomorrow in class.